Here we want to find out why the derivative of arctan of x is 1 over 1 plus x squared. Remember that arctan of x is the same as tan inverse of x. So first we start with this. Tan arctan of x is equal to x. Now what we do is take the derivative of both sides. So dx of tan arctan of x, and then the other side will be dx. Now to differentiate this term we have to use the chain rule. The outside function is tan and the inside is arctan of x. So the derivative of tan is 1 over cosine square of what's inside the derivative, what's inside the parentheses, in this case arctan of x, and then we multiply it by the derivative of the inside, in this case is arctan of x. And remember, d of dx is just 1. Now what we want to do is move the term 1 over cosine square to the other side. So I'm gonna multiply both sides by cosine square arctan of x, and then the right side will be just cosine square arctan of x. Now what we can use is to use a trig identity. That gonna be 1 plus tan square theta gonna be 1 over cosine of 2 theta cosine square theta. Now we want to solve for cosine square of theta, therefore it's gonna be 1 over 1 plus tan square of theta. Here in our example, theta is arctan of x. So I'm gonna take that and substitute for cosine square. So that's gonna be 1 over 1 plus tan square, and again theta is arctan of x in this case. Now what I'm gonna do is I'm gonna take this term tan square arctan of x and I'm gonna rewrite it in a different format to find its value. So the term can be written as tan arctan of x all squared. Now again tan inverse is just x, and gonna be just x squared for that term. So plug that term into this fraction, it's gonna be just 1 over 1 plus cosine square, and that's it, the derivative of arctan of x. We can apply the same thing for the derivative of arcsine of x. And the resulting will be 1 over square root of 1 minus x squared. Here we have these examples and we want to differentiate them. So we start with a, we have arctan of t squared and we want to find its derivative. What we do is remember, the derivative of arctan will be 1 over 1 plus x squared, or what's in front of the parentheses. So since we have t squared here, it's gonna be 1 over 1 plus t squared and squared again. So pay attention to this. And then 2 multiplied by 2, it's gonna be the power of 4. This is again, we have to use the chain rule in here since we have t squared. So I'm gonna multiply the derivative of the outside by the derivative of the inside. I'm just now arranging these, so it's gonna be 2t over 1 plus t to the 4th. to the 4. Now for b, we have arcsine tan of theta. We already know what's the derivative of arcsine and the derivative of tan. Therefore, we already differentiate this function. So our variable here is gonna be theta. And remember here, we gotta use the chain rule. So the outside function is arcsine, which derivative will be 1 plus minus x squared, or what's inside the parentheses. This is gonna be tan theta all squared, and then multiply by the derivative of the inside, which is 1 over cosine squared of theta. Now I'm just arranging these terms, and that should be our answer.